Since the Industrial Revolution, the emission of CO2 increases year by year. The greenhouse effect is progressively getting worse. In modern society, this topic is valued upon. If we keep ignoring these problems, the temperature will keep on rising, causing the glaciers in the North Pole to melt, raising the sea level, flooding the lowland areas. Some island countries might even lose their land, thus creating many climate refugees. Additionally, due to the advancement of medical care, the global population is increasing in an alarming rate. First of all, we will have to face food crisis. Is there a method that can both solve the two global crises? Come with us and let us find the solution together. Our prototype is divided into 4 parts. The first part is where the CO2 is concentrated. We use recycled plastic bottles to represent the machine and connect it by tubes so the air can flow freely between. One of the tubes is connected to the ground. That is for storing CO2, which can be used in the future. The second part is the battery, which is made out of recycled cardboard. The metal-like inside is made out of recycled aluminum foil package. The colored cellophane was used to be decorations for other school projects. We use them to represent the chemical liquids in the battery. The third part is a greenhouse. We recycled a plastic jar and made it as a greenhouse. An old light bulb was placed on top of the greenhouse for lighting, and a tube was placed on top of the greenhouse as well for watering. The electrodes from the battery and the light bulb from the greenhouse was connected with metal wires. The last part is the water storage. A plastic bottle represents the storage. The bottle and the greenhouse is connected with a tube. Water will be transferred to the greenhouse. A new way of removing carbon dioxide from a stream of air could provide a significant tool in the battle against climate change. A new system invented by scientists can work on the gas at virtually any concentration level, even down to roughly 400 parts per million currently found in the atmosphere.
Most methods of removing carbon dioxide from a stream of gas requires higher concentrations, such as those found in the flue emissions from fossil fuel-based power plants. A few variations have been developed that can work with the low concentrations found in air, but the new method is significantly less energy intensive and expensive, the researchers say.
The device is essentially a large specialized battery that absorbs carbon dioxide from the air or other gas stream, passing over its electrodes as it is being charged up, and then releases the gas as it is being discharged. In operation, the device will simply alternate between charging and discharging, with fresh air or feed gas being blown through the system during the charging cycle, and then the pure, concentrated carbon dioxide being blown out during the discharging.
As the battery charges, an electrochemical reaction takes place at the surface of each of a stack of electrodes. These are coated with a compound called polyanthraquinone, which is composited with carbon nanotubes. The electrodes have a natural affinity for carbon dioxide and readily react with its molecules in the airstream or feed gas, even when it is present at very low concentrations. The reverse reaction takes place when the battery is discharged, during which the device can provide part of the power needed for the whole system, and in the process ejects a stream of pure carbon dioxide. The whole system operates at room temperature and normal air pressure.
We plan to use this method to reduce CO2 in the air, and the CO2 we capture will transfer to a battery that utilizes CO2 to generate electricity. If there is extra CO2, we will store it underground.
Then, we transfer CO2 to a big liquid battery, which is called hybrid NaCO2 system. When CO2 is injected into the aqueous electrolyte, it reacts with the cathode, turning the solution more acidic. which in turn generates electricity and creates hydrogen. In tests, the team reported a CO2 conversion efficiency of 50%, and the system was stable enough to run over 1,000 hours without causing any damage to the electrodes. Unlike other designs, it doesn't release any CO2 as a gas during normal operation. Instead, the remaining half of the CO2 was recovered from the electrolyte as plain old baking soda. Last but not least, we will transfer the electricity from Na-CO2 hybrid system to the greenhouse. The hydrogen is for igniting fire along with oxygen to help it burn, creating H2O. We will then store it and use it on the greenhouse. The reason we chose greenhouse cultivation is because it can grow crops in places which is not easy to grow plants. It will not be affected by the surroundings, and we can control the humidity and lighting. Due to these points, we can produce crops more efficient, achieving the goal of increasing food supply. Our greenhouse will use drip feed so that we can use the water efficiently. We can also accelerate the speed of the growing crops by adjusting the lighting. We hope this system can bring food to those places that cannot grow crops, and also can decrease CO2 in the air. The hydrogen created by Na-CO2 hybrid system not only ignite fire along oxygen to help it burn, but also become the fuel of hydrogen car. In addition, H2O that is also created can be applied on agriculture. If all the cars change into hydrogen car in the future, it can solve the problem of oil shortage, and also can decrease the emission of CO2 during the transfer of the food. There are other ways to reduce CO2 and add food supply. Take the method of using plants to generate electricity as an example. Electrons are a waste product of bacteria living around plant roots. Plants excrete organic matter into the soil, which is broken down by bacteria. It is possible to harvest them using inert electrodes and turn them into electricity. And it can increase food supply at the same time. However, the system has a disadvantage, that is the plant cannot be grown on dry places. The system cannot produce water, thus causing water shortage, and with no water, no plants can survive. Our method contains a way of producing water, that is burning hydrogen and oxygen together. Hydrogen was created by the Na-CO2 hybrid system, so it is easy for us to create water for the crops in the greenhouse. That is why we can grow plants in places that is not suitable for plants to live. However, there are still some disadvantages in our system, including the cost of the system. Undeveloped countries might have a hard time to solve this problem. The second disadvantage is the space the system needs. It will take up lots of space to function. These problems can be solved in the future, and we will keep on moving forward to make the world a better place.